Hello everyone. Welcome back to the last lecture from the design of shaft and keys. Okay. Today we will see one problem on the design of key. As I told you previously only, design is all about the problems. Okay. So you have to concentrate more on the problems. Okay. Almost 70 marks are of problems only. Hardly you will get 30 marks theory. Fine. So you should be a very good in solving the problem. So you can practice it in home. Okay. Next, I'll read out the problem. Design the rectangular key. Okay. So problem says we have to design a rectangular keys. Now designing means what? We have to check for the stresses. We have to find out the dimensions. That itself is the design. Okay. For a shaft of 50 diameter, okay, we have to design a key for the shaft who has the diameter of 50 The shearing and crushing stress, the stresses which are acting on the keys, they are given as the 42 megapascal and the 70 megapascal. Okay. So as I told you, and I will be telling you, okay, when you go for solving the problem, first try to gather the data from the problems. What is given, what is required to find out. Okay, that is very important. Okay, so picture will be a clear if you are having the correct given data and what is to be find in your mind. Correct. Next, after writing the given data, I will start solving the problems. Okay. Now when you open your data handbook, okay, there are standard dimensions of the keys for the standard dimensions of the shaft. Okay, for diameter equal to 50 we will be having the width of the key as a 16 This you will get directly from your data handbook. Okay, you just go to the table, you find out the diameter of the shaft. Okay, in this case it is the 50. So for 50 we are having the width is 16 and thickness as the 10 Okay. Next, now we have to obtain the length of the key. Okay, by considering the shearing and the crushing stress. Okay, in problems in a given data, we saw that crushing and shearing stresses they are already given in the problem. Okay, so let's consider L be the length of the key. Now we know the shearing strength of the key T equal to L, that is the length of the key, W is the width of the key, tau is the shear stress, and D is the diameter of the shaft. Okay, now expect value of L. Okay, we know all the values. Okay, go and substitute. So so L is as it is because we don't know the value of L. W is the width of the key, which is already given in the problem as 16 Shear stress given as the 42 42 Newton per square. Diameter of the shaft is 50 Okay, the 50 by 2. So once you solve this, you will get a torque as 16800 into L Newton Now still we haven't got the exact answer. The answer is in terms of L. Okay. Now we also know that the torsional shear strength is given by T equal to pi by 16 into tau into D cube. Okay. So pi by 16 into tau is 42. Okay. D is 50 cube. Okay. So what you will get is 1.03 into 10 raised to 6 Okay. Now we have to apply the maths rule. Okay. When the left hand sides they are equal, then the right hand side must be also equal. When equate the right hand side, we'll get the length of the key as the 61.3 Okay, that is by using the shear criteria. Here also they have given it is subjected to the crushing stress. So use the crushing stress formula. T equal to L, okay, into T by 2 into sigma C into D by 2. Okay, so substitute here. L we don't know. T by 2, that is thickness divided by 2 into 70, that is the crushing stress. D is 50 that is the diameter of the shaft, divided by 2. We will get 8750 into L Newton mm. Now this we have to equate it to the previous, the torque which already we found out, correct? When you substitute value of torque and if we transfer this 8750 to other side, we'll get the length of the key is 117.7. okay, so now what we have to do is we have to compare the length. See, in previous we got L equal to 61.31. Here we got the length as 117.7. So always remember you have to take a maximum length. Okay, so maximum is 117.7. okay, but the standard is say 120 will be the length of the key. Fine. I hope the all the problems are clear from this chapter, and we'll starting the next chapter shortly, that is the design of fasteners. Thank you.